Okay, continuing with our video lessons. Today we're going to continue with the exercises on page 100. Remember now the topic that we're seeing are triangles. Okay, postulates for isosceles triangles and right triangles. Okay, so let's continue with the exercises on page 100. Okay, so we're going to work these two triangles. Okay, so it says, example, in the drawing to the left, AB is congruent to AC. Okay, so let's locate AB. This one is congruent to AC. Okay, and they're already marked as congruent. Okay, now, and the point P, this is a point where we have to check where it is, okay, is on the bisector of angle BAC. Okay, so the bisector, remember, that is a line that separates in the middle. Okay, so this is the bisector. Okay, this line, they didn't put a name here, but let's put a D. Okay, so line ADP is on the line that bisects the two triangles. Okay, well, one triangle, right? BAC. Okay, but the line AD has a point, okay, which is the point in the bisector of angle BAC. So what are they asking from us? They're asking us to prove that BP, which is here, BP, is congruent to CP, which is here. Okay, these lines. Okay. Now, what are they giving us? They are giving us that line AB, which is here, is congruent to CD. Okay. Now, CD is not given, but it's here. So BP is congruent to CP. I'm guessing that's what they wanted to say. Okay, here. Okay, so AB is congruent to CD. Okay, and we want to prove that BP, which is this line, is congruent to CP, which is here. Okay. Now, in this one, A, B, and CD, we didn't have D. I'm guessing they wanted to say AC. Okay, this one is wrong. Okay, this one should be AC. Okay, because here we don't have D. D, I'm putting it here, but it is not included. Okay, I'm just putting it as a reference. Okay, so let's see what we have. AB, which is this one, and AC are congruent. Okay, remember that this should be AC. Okay, and this is a given, right? They're giving us this. They're also telling us that the point P is on the bisector of AP. This is also given, okay, because they're telling us that this point P is here on the bisector of this line. Okay, and that's also given. Now, look at what we have here. BAP, which is here, look, BAP, this angle is congruent to CAP. Why? Because it's the bisector. Look, if I have this whole angle here, angle A, and I have a line that bisects in the middle of this angle, that means that this angle is congruent to this one. Let's say that angle A measures 40, for example. Okay, if I divide it, if I have a line that divides it into two, that means that each angle is going to be 20 because it bisects exactly in the middle. Okay, so that means that BAP and CAP are opposite angles to sides that are congruent. Okay, but here we're just saying, okay, remember, if this side is congruent and this side is congruent, okay, remember, the rule that we saw before, okay, was telling us if two sides of a triangle are congruent, then the angles that are opposite to these sides are also congruent. Okay, so that means that if this side is congruent to this side, that means that their opposite angles are congruent. And what is the opposite angle here? This one, look. But we haven't touched that angle yet. But if this side is congruent, the opposite angle is congruent. If this side is congruent, the opposite angle is congruent. Okay, but here they're telling us BAP, which is this one, BAP, is congruent to CAP. CAP. Okay? Now, opposite angles to congruent sides are congruent. Okay, we already know that. Now look at here. Side AP is congruent to side AP. Why? Because it's reflexive. AP is what? Here. So that means that this line is congruent with this triangle and it's congruent with this triangle. Okay, entonces, ¿qué dijimos? Opposite sides that are congruent are equal to the opposite angles. Entonces, what is the opposite angle of this side? Here. Meaning opposite side, opposite angle. Opposite side, opposite angle. Okay? Now, look at what we have here. If this side is congruent with this side, so we have one side. These two angles are congruent. Okay? And then these sides are congruent. So what postulate can we use where we have side, angle, and side? The SAS postulate. Okay, because this side is congruent with this one. This side is congruent with itself. And these two angles are congruent because they bisect. They have a bisector that separates the two angles into equal parts. So that means that when we bring it here, why is this triangle congruent with this triangle? Because of the side, angle, side postulate. Okay? And the side that actually helped us is the one that is reflexive, right? AP is congruent to AP. So that means that the side AP is congruent to itself. Okay? Congruent segments. Okay? Now, once we know that BAP is congruent to CAP, okay? BAP, this triangle, is congruent to CAP, which is this one, okay? And that is because of the side, angle, side postulate. Okay, so BP is congruent to CP. Okay, so this one is congruent to this one. Why? Because the two triangles are congruent. Okay, if we already proved that these two are congruent because of side, angle, side, el otro lado tiene que ser congruente, por fuerza. Okay, because we already know that they are congruent because of the side, angle, side postulate. Okay, entonces these two are congruent, ¿por qué? Because of the side, angle, side postulate. O sea, técnicamente aquí podríamos haber puesto lo mismo. But since these two sides are congruent, these two angles are congruent, and this one is congruent to itself, significa que se usa para este triángulo y para este, then we know that the angles are congruent and that the other side is also congruent. Okay? Let's look at the next example. It says, using the postulates of congruent triangles for ABD and ACD shown in the figure to the left, which is this one, prove that AD is perpendicular to BC. Okay, now we're going to, it changes a little because they're asking for perpendicular. Okay? And then AD is perpendicular to BC. And then AD bisects angle BAC. Okay? So we know that this side, this line, AD bisects BAC, which is this complete triangle. Okay, so this line AD, it's congruent to itself, that is with the identity property or reflexive property. Okay, we know that these two sides are congruent. Okay, and we also know that BC, since it's D in the midpoint, okay, it separates these two sides into congruent sides. Okay, but let's see what we have in the proofs. Okay, so they're asking us, AD is perpendicular to BC. Okay, so they're saying, okay, AC is perpendicular to BC. Yes, because they have a point here, but let's see what happens. It says, AD is perpendicular to BC. Let's work on the proof. ABD and ACD are congruent. Why? They're telling us by the previous proof. Okay? Because these two are exactly the same, so we're using the information from this proof here, okay, by the previous proof. Okay, we know that they are congruent. Okay, now look at what happens here. The measurement of angle BDA, okay, which is here, BDA, we're talking about this angle here, is congruent to CDA. Let's see, CDA, this angle. Okay, and why? Because the triangles are congruent. We already know that this triangle here, triangle number 1, is congruent to this triangle number 2. Okay, and we know that they are congruent. Okay, but we're trying to prove that AD is perpendicular to BC. Okay, so the measurement of BDA is congruent to CDA. Why? Because the triangles are congruent. Okay, this one is equal to this one is going to be equal to this one, and this angle is going to be equal to this angle. Okay, and we already know that the sides are congruent. This side with this side, these two with this two, and this one by itself because of the reflexive property. Okay, so then we have the measurement of BDA, which is here, BDA, and the measurement of CDA is going to give me what? 180. Why? Because if this angle measures 90, how much is this one? If they're congruent, 90. And the measurement, the addition of both has to be 180. Okay, why? Because they form a linear pair. Okay, a linear pair is just telling us that. Remember that when we put this into a coordinate plane, this was not very straight. Okay, when we put this into a coordinate plane, okay, remember, the movement from here to here is 90. The movement from here to here, 180, okay, starting from here. The movement to here is 270, and the movement to here is 360, okay? So, if we have this, if we have a straight line, okay, how much is this movement? 180, okay? So, if you notice, the distance from here to here is 180, and since these two are exactly equal, one is 90, the other is 90. Okay, then what do we have here? The measurement of BDA, which is here, BDA, the measurement of this one, okay, is equal to CDA, which is this one, CDA. They are equal. Okay, so both have to be 90 because of the substitution property. What substitution? That if all of this is 180, this has to be 90, this has to be 90. Es como yo les decía acá arriba. If this angle A is 40 y lo pongo una línea que lo divide entre dos, one has to be 20, the other one would be 20. The same thing happens here. If all of this line is 180, if I divide it between two lines, between two angles, one has to be 90, the other has to be 90. Okay, so we can call that substitution property. Okay, now if we know that this is 90, this is 90, that these two sides are congruent, that these two sides are congruent, that this side is congruent, we already know that these two triangles are exactly the same. Okay, but how do we know that they're perpendicular? AD will be perpendicular to BC. Okay, so AD will be perpendicular to BC because of the definition of perpendicularity, which is the definition that if we have this, look at here, side, angle, side, side, angle, side. We know that they're congruent, okay? And we know that point D, okay, is the midpoint. They didn't put it here, but we know that it's the midpoint where the line AD and BC meet, okay? So if we know that they have the same measurement because they are congruent, okay, then we have a point where they meet, which would be point D, okay, which would be the midpoint between BC. But D is not the midpoint of AD. This is just where they meet. Entonces, si tenemos este punto donde ellos se encuentran, line BC meets AD, and they have two angles that are exactly the same, then we know that they're perpendicular. Okay? Porque si este ángulo fuera mayor que este, ya no son perpendiculares. Okay? They have to have the same measurement. Okay? Cuando yo divido un ángulo entre dos, they need to have the same measurement. If they don't have, ¿qué tal si esta línea hubiera estado un poquito más inclinada para acá? Que hubiera caído aquí. Entonces, this side is no longer congruent with this side. Entonces ya no serían perpendiculares. Okay? Simplemente se unirían en un punto, but they wouldn't be perpendicular. Okay? Because the definition of perpendicularity tells us that these two angles need to have the same measurement. Okay, so if we have two lines that meet at a point and they create two exact angles, then they are perpendicular. Okay, now let's see what happens here. AD bisects angle BAC. Okay, so AD, which is this line, bisects BAC. Okay, we already know that, right? Because this line bisects in the middle of this angle here. Okay, so what do we need to prove? Look, ABD is congruent to ACD. Ya sabemos, ¿verdad? This triangle is congruent to this triangle. ¿Por qué? Because of the side postulate. All sides are congruent. Okay, by the previous proof, pero la verdad, it's because of the side postulate. Okay? Now look at what we have here. The measurement of BAD, which is here, BAD, they're telling us that it's congruent to CAD. Okay, why? Because the triangles are congruent. Y esto ya lo sabemos. Why? Because of the side postulate. Okay? So they're telling us AD bisects angle BAC, okay, here. BAC, remember that it's the whole triangle. BAC, it's the whole triangle. No los dos pequeños, the big one, okay? And why do we know that AD bisects this triangle? Because of the definition of an angle bisector. ¿Qué es lo que nos dice el angle bisector? That if a line moves between, okay, and separates two triangles into equal parts, these two angles are congruent, and these two angles in the bottom are also congruent. Okay? Entonces, por ende, nosotros, miren, inmediatamente, we already know that these two triangles are congruent, because if this line separates here, ya sabemos que este es congruent to itself. We know that this angle is congruent with this one. We know that this one is congruent with this one, porque los separa en dos. So we already have angle, side, angle postulate. We already have it. So ya inmediatamente sabemos that they are congruent. Okay? Inmediatamente, solo con ver esta línea AD, I already know that these two triangles are congruent. Okay? Because todo este ángulo se parte en dos. Y todo este ángulo A se parte en dos. So if this line is congruent to itself, we already have angle, side, angle. Okay? So inmediatamente nosotros ya sabemos. Okay, so AD bisects angle BAC, yes. Definition of an angle bisector, de que divide en dos partes iguales los ángulos. Okay, look at this rule. If any triangle, in any triangle, the bisector of an angle between two congruent sides is perpendicular bisector to the opposite side. Entonces, ¿qué nos están diciendo? Miren esta regla. This is very important. In any triangle, como este, The bisector of an angle between two congruent sides, miren, two congruent sides, ¿cuáles son? This one and this one. Estamos hablando de esta línea, AD. Si esta línea parte este triángulo entre dos congruent sides, okay, between two congruent sides, then it's the perpendicular bisector of the opposite side. ¿Cuál sería el opposite side? BC. Okay, so that means that AD is perpendicular to BC. Okay, esta es la regla que nos está diciendo that they are perpendicular, meaning in any triangle, como este de arriba, any triangle, the bisector of an angle, o sea, esta línea bisects this angle into two equal parts. Okay, so the bisector of an angle between two congruent sides, que sería this congruent side and this congruent side, okay, is the perpendicular bisector of the opposite side. ¿Y cuál sería el opposite side of this bisector? Here. No sería este, porque la está más bien partiendo. Okay, so what would be the opposite side of this line? Here. So that means that they are perpendicular. Okay? Perfect. So make sure to check the link under this video, okay, for more exercises on these triangles. Okay, make sure to check them out, and if you have any questions, please let me know.